So in this video we're going to talk about subtracting polynomials. Subtracting polynomials is the exact same concept as adding polynomials, except when we're distributing the subtraction sign in, we're going to have to actually change all the signs of the inside brackets. So again, we will start by removing the brackets, being careful about that subtraction symbol that is distributed in. We will then reorder the groups of like terms, perform the appropriate operation needed, and then always write in standard form your final answer. Here are some examples. X squared minus 5x, we will distribute the positive that is not shown, but it's applied, the positive inside to the bracket. Again, we just drop the brackets, there's nothing really to be done there, but the math behind it is to drop the bracket, we are kind of distributing in a positive there. This is where most people get in trouble, this negative sign, the subtraction sign. A negative distributed into the 2x squared and the negative distributed into the negative 8x gives me negative and a positive is a minus 2x squared. A negative and a negative is a positive 8x. So once again, we distribute the negative sign into the brackets. A negative and a net positive gives me a negative 2x squared. A negative and a negative give me a positive 8x. Now that I've got rid of the brackets, I will reorder them with like terms. X squares are with x squares, so I put them together. My x's will be with x's, so I put those like terms together. Keeping in mind this minus 5x here will be a minus 5x there. Do not make sure you don't just drop the 5x down. Make sure it becomes a minus 5x. You got to be really careful with your signs. That's the tricky part about the polynomials. Now we will do the appropriate operation. 6x squared minus 2x squared. 6 minus 2 is 4x squared. Remember, this is a negative 5. So negative 5x plus 8x. Negative 5 plus 8 is a positive 3x. So then I look for standard form. X squared comes before x to the power of 1, so this is in standard form and you're done the question. We can now look at a little bit more of a challenging question. Again, in front we have a positive sign which isn't shown but it's applied, so obviously we just drop the brackets and we rewrite it the way it is. This subtraction sign will be distributed into all three terms here of this trinomial. So again, be careful with that subtraction symbol when you're distributing. A negative is a positive 3x cubed. A negative and a positive is a negative 6x squared. And a negative is a positive 2x. We will rewrite them with like terms. All your x cubes will come together, so 7x cubed plus 3x cubed gives me 10x cubed. We will have all our x squares, and this is a negative 2x squared, so negative 2x squared minus 6x squared. Negative 2 minus 6 is a negative 8x squared. Those are like terms. And now I have my x's, so plus 5x and a plus 2. And I'll combine those terms to get plus 5 plus 2 is a positive 7x. I look for standard form. X cubed comes before x squared, and x squared would come before x's, so this is written in standard form. Usually when I am rewriting it and regrouping, I will regroup it in standard form. You don't have to, it just saves this spot at the end. If you regroup it in standard form, putting your highest degrees first, then it makes your standard form part a lot more easy. So let's look at this when we're dealing with models. When we're dealing with models, we are going to do something called the additive inverse. Now to do that, essentially what we're doing is we will model the first part 3x squared, so 1, 2, 3x squares, and they're positives, minus 2x's, so we have our white negatives. The additive inverse is when I am actually distributing this negative sign into the brackets And essentially what I'm doing is I'm adding its opposite. So instead of minusing 2, so these are white ones, I'm going to go a negative and a negative is a positive 2, and a negative and a negative is a positive 5. So this negative 2x minus 5x changes to a positive 2x plus 5x. It's called the additive inverse. And then I can just add these together. Now there's no zero modeled with the x squares, so I'm left with 5x squared. The 2x's, the negative 2x's, get canceled with the zero model, so these ones are all canceled out, and all I'm left with is 3x's on the bottom, and I'm left with 5x squared plus 3x. Like subtraction, or like addition, be careful when you're doing your cancellation that your negatives cancel your positives, but because it's subtraction, your second group of polynomials, your second group of algebra tiles, you're going to have to be very careful when you're distributing that negative sign in, so that these are actually colored in properly, so that you're actually a negative is a positive number, and a negative is a positive. Be very cautious with that. That's the biggest mistake people make. And the last thing is we will learn how to subtract polynomials vertically. Just like addition, we can line them up in order of degrees, just like we would do with decimals. But again, we are going to add its opposite, the additive inverse. So instead of minusing a positive 2x, I'm going to add a negative 2x. So what I'll do is I'll distribute into the brackets, and I will write this as an addition statement, and then I can just go straight down and do what the operations say. Makes it a lot easier. So this is a negative 2x squared, a minus and a positive is a negative 2x, and a minus and a positive is a minus 5. Now because I'm adding, I've changed it to an additive inverse. 5x squared minus 2x is 3x squared. Minus 7 minus 2 is minus 9x. Plus 4 minus 5 is a negative 1. And this is written in standard form. X squares come before x's, which come before constants. And 3x squared minus 9x minus 1 is my final answer.